Hello all, welcome to Module 1 Python Language Essentials. This is part 2 in which we will discuss variables and data types. Now in Python there is something very interesting about how variables and objects work together in comparison to other languages. So what is that? In Python, variables or names which you actually try and give objects basically do not have any type associated with them. Interestingly, types are associated only with objects, and variables basically just have references to these objects. Now, what do I mean by that? Let's open up a Python terminal, and let's say I create a variable called name, which is simple string called Vivek, right? Now, typically, if you remember other languages, you would ideally have to define this as a string and things like that. In Python, you don't need to do that at all. Now, you may assume if you're coming from other languages that now name basically can only be a string. Not true at all in the case of Python. Why? Because the variable name is not associated with any data type, rather it is just a reference to objects. Now it is this object which is this string Vivek which has a type string associated with it. To prove my point, in the very next statement I am going to assign the number 10 to name, and it just works perfectly. So basically, if you're coming from languages like C, think about name to be like a pointer to the string Vivek, which is the object. So hence, name itself does not have any type associated with it. Rather, it is the object which has the type associated with it. Now, coming back to our presentation, if you were interested in finding out the exact memory location in which the object is stored, you can do it in two ways, by either using the id function or going ahead and using repr, which is an attribute inside the respective object. So here is an example. So let's say I want to figure out, let's clear the screen. Let's once again assign Vivek to name, and we want to find out the exact memory location where Vivek is stored. Then this is what it is, right? You could probably want to print this in hex by actually feeding it through the hex function, and this is the hex value. Another way to figure this out, which we'll get to much later, is this, where if you notice this value is exactly the same as this value here, right? So this is the exact memory location where the object is stored, and name is nothing but a reference to that object. Now with this basic concept all cleared up, let's look at different data types which Python offers. Now the first one is string, which I'm sure most of you are familiar. There are multiple ways in which you can define strings. You can use both double quotes, single quote. At the very same time, you can have escape sequences inside. Let me show you a quick example of how all of this is done. So let's say we already defined a string Vivek using our little double quotes. We could do the same using single quotes as well. Just hit name and you can see the value which is there inside. You could have escape sequences inside. Let's say we want to go ahead and say Vivek and then Ramachandran in the next line, right? So this is how name actually looks like, and when you do a print name, you would actually see that the /n is interpreted as a new line and it gets printed accordingly. Now if you wanted that even this should get printed and not interpreted, you could actually go ahead and create what is called a raw string. So you could say Vivek and then with the R option, and now if I do a print name, as you notice, the /n is no longer interpreted as a new line. Rather, it is just part of the string. And the way we did it was specifically telling Python, this is a raw string and do not interpret any escape sequences. Now, one of the other ways, if you want to add a little bit of formatting so that you can type stuff up, have multiple new lines and stuff like that, is going ahead and actually using the triple quote block string declaration. How do you do that? Well, you could say name equals, and then you can say Vivek Ramachandran teaches at SecurityTube. This is going to be a fun class, I hope so. Then finish the block. Here is what name looks like. And if you notice, all the new lines and stuff which I entered is automatically placed inside the string. And when you print this out, it prints in the same natural way in which I entered it, right? So interesting ways in which you can define strings. The triple quotes at times is also used as a commenting feature in Python, as we will see later on. Now, one of the other things I wanted to touch upon is that apart from the regular ASCII strings we are used to, Python also supports Unicode strings. Now, if you've not heard about Unicode, Unicode is used for internationalization. Why? Where there are hundreds of languages with special characters and interpretations and whatnot. And that's where Unicode, also referred to as wide characters, allows you to encode all of these different letters from all these different languages in an easy way. Now, how do you go ahead and define a Unicode string? Similar to what you did in the raw case, in the case of Unicode, all you need to do is prefix U before you define the string. Now when I hit name and just enter, you would actually notice this U here tells us that this is Unicode. To convert a Unicode string into a regular one, you can use the str function, and this converts it into a regular string. Alternately, to convert a regular string into a Unicode string, you use the function Unicode, and this converts this into a Unicode string, right? Keep this in mind, especially when you look at web applications where the encoding and all that comes into picture. We will see that understanding Unicode is essential in parsing many of those responses. Now, let's look at different string operations. The interesting thing about Python is in Python, strings are immutable objects, which is once you create them, you cannot change them anymore. Now, what do I really mean by that? Let's say I again go back and define a simple variable name, and let's actually go ahead and call this Vivek, right? Now, if I try and change, or let me actually try and look at what is there in the 0th index. As expected, it is the character V. If I try to change this to, let's say, A, you would actually notice that it says type error, string object does not support item assignment, which basically means you cannot change string objects directly in memory because they are immutable. Now, the only real way is actually to go ahead and assign this to an absolutely new object. Let's say Ramachandran, right? And this would work perfectly because the Vivek object still does exist. All that has happened is that now we've created a new one called Ramachandran and referenced it with name. To prove this, let's say we have A is equal to name, which is we are creating two references to the same object. Actually, A is equal to Vivek, and then we say, hey, name is equal to A. What this does is now the name variable also refers to Vivek, right? And so does A. Now let's say we go ahead and say A is equals Ramachandran. Here you go. But if I again print what name references, you would notice it continues to reference the object Vivek in memory. So this is how strings being immutable cannot be changed. However, the variables which are just reference to these objects can be changed to refer to other objects. Now, if you want to concatenate two strings, let's say first underscore name is equal to Vivek, and then you have last underscore name is equal to Ramachandran. And if I would like concatenate name and I call this full name, I could just write in first underscore name plus last underscore name, right? And if I print out full name, there you go, right? Ideally, we would have preferred a space between the first and last name, and it is as easy as just concatenation of a space in between, right? This is how we concatenate strings. People from the C world would probably be amazed. In the case of C, you would have to do strcat or play with memory, tons of stuff to do, but here it's just as simple as this. Now, Python, like most high-level languages, has garbage collection, which is once any object is no longer referenced by a variable, it is typically automatically freed up by the system. This ensures that the free pool of resources in memory is automatically taken care of rather than an object just lying in memory which we will never use, right? So typically in languages like C, you would have used free to free up memory associated with any allocations you've done. Python takes care of most of the garbage collection entirely by itself. Now, other interesting things is if you want to create a repeated sequence, you could just use the asterisk, almost like the multiplication sign, and do it. And then you have slicing, which is breaking up the string into different parts. Let me take both of these up. So typically when we look at things like buffer overflows, you would probably want to create a very large buffer holding the same value. So let's say 50. And if we now look at buffer, this is nothing but 50 A's which are there, right? Now, let's say that you have a string coming back to actually slicing strings up. Name equals Vivek Ramachandran. And let's say I actually want to slice this string up. Let's say I would like to go ahead and slice it up after the 5th and end at the 10th. And if you actually notice, at that point, 5th is basically 0, 1, 2, 3, 4, and 5. From this point on to the 10th, and which basically gives us RAMA, 1, 2, 3, 4, 5, from that point onwards to A, which actually ends here. Now, there are other interesting things which you can do as well, which is mention the number of steps which need to be taken, right? And this is basically using a step of 2 rather than taking every single one between them. Now, we will revisit slicing a little later when we do string manipulation and stuff like that, when we take up actual practical circumstances, right? One of the other ways, by the way, which is very interesting, is a string converted into an integer. For that, you could just use the int function and enter the string, let's say 42, and the output is the number 42. Vice versa, you can use the str function, input a number, and the output is going to be a string, right? Some of the more interesting string methods basically include find, replace, split, and a bunch of others. Now, I'm touching upon some of the more common ones which we would use. In later modules, when we take up anything specific which I have not really covered here, I would explain how it works. Now, I can tell you in any new language, there are probably hundreds, if not thousands, of methods, functions, and whatnot which the language provides to you. It would probably be impossible to cover each and every one of them in this video tutorial. So what I'm actually doing is I'm picking up stuff which is most important so that you know how to get started with the Python language, and later on your own you can explore other methods, other functions which the runtime offers to you. Okay, so find, replace, and split. So let's say we have the string name, which is Vivek Ramachandran. Now in this, let's say you want to go ahead and find if security tube actually is there. Now if find succeeds, then what it returns is the starting point index from where the match occurs. If it fails, it returns -1. So in this case, of course, name Vivek Ramachandran does not contain security tube, and hence the response is -1. On the contrary, if the substring to search for is Rama, you would actually notice that it says it is at position 6. Right? Similarly, if you want to go ahead and split the name into the first and last name, you can just use name dot split. By default, split splits across white spaces and basically creates a list after the split. We'll visit lists in just a bit, so please be patient. Now the interesting thing is that split itself can take the delimiter used for splitting as an input. So as an example, let's say I go ahead and take the word A as the split character, then this whole string would actually be split into different parts around A. Here is how it looks, right? So if you notice, the very first A is here at this position, and hence this is the first output which we get, Vivek space R. After that you have just M, after which you see the next A, so we have M, and then you have C and H, again the next A, and then you have NDR, again the next A, and then finally N. And if you notice, this is how the split has happened, right? So split comes in handy when you know the delimiter and you also know how you would like to organize the split list for better use later on. The last function I'd like to touch upon is basically replace. Now replace, the first input would be what to search for. So let's say I say Vivek, and then to replace it with whatever else you would like, let's say Viv, right? The interesting thing is the replacement can be smaller than the string it is replacing. So if you notice, the output is Viv space Ramachandran. Now interestingly, if you type in name, you would still get the original one. Why is that? Because if you remember, I had mentioned that strings are immutable. So the name variable points to an object Vivek Ramachandran which can never be changed, and hence all of these functions are returning new objects rather than modifying the original object containing Vivek Ramachandran, right? Hope this concept is clear to you. Okay. The next thing we will look at is string formatting, right? A lot of times you would want to print out interesting things. How do you go about it? Now, the first technique is actually to go ahead and do something similar to programming languages like C, where you actually go ahead and put in the formatting identifiers like %s, %d, and then go ahead and fill up those values inside those placeholders using variables. So as an example, let's say we have a simple line, and we could call this, before that, let's say your IP is equal to 10 or 192.168.1.10. The line which we could mention is crack this IP percentage is, and then what I could actually mention is the IP address. Now I put in a line, and if you notice, the substitution here for IP has actually happened inside the string before it was constructed and referenced by line. Now you could have multiple such things inside, and name percentage S, where basically you could go ahead and have the name as security tube, right? And now this line would basically reference that as well. Now similarly, you could mention dictionaries as input as well, which we'll cover later on when we cover that data structure. The basic takeaway here is that you could use different variables and formatters to create interesting strings based on what you would like to display. Numbers are something probably very simple to get a grasp of. Just like other programming languages, Python has integers, floats, and a bunch of other things. We will take up specific types of numbers as and when required during the class in different modules. As far as operators are concerned, you have the usual suspects: plus, minus, multiply, divide, x to the power of y, greater than, equal to, less than, ton of other things, and of course your bitwise operators, right? And after that, your logical operators. So we will take up numbers as and when required. There is nothing much to explain here. You could even use the Python prompt as a simple calculator, by the way. So let's say 2 plus 2, and it says the answer is 4, right? So you could go ahead and use that as a replacement for BC. Okay, so now coming on to another interesting data type, which is lists. Now lists are collection of objects, and interestingly in Python they can be heterogeneous, they can be nested, and they are very interesting data types which you will use time and again in this course. Let me give you a quick introduction about lists. So let's say I call something my list. It's a simple list of numbers to begin with, right? To find the length of this list, all you have to do is use the len function, and this gives 3 as expected. To go ahead and reference any of the list items, you basically start with a list index of 0 and go all the way to n minus 1, which is the number of items in the list, right? Now these lists can actually be nested. So as an example, you could have my list equals 1 comma 2, and then you could have another list which basically says 3 comma 4. And when you go ahead and do a quick len on this, you would actually notice the length remains 3. Now if you want to know the length of any of the items, then you could actually, let's say, do this, where here of course it's not going to make any sense because 1 is nothing but a simple integer where len has no meaning. However, when we do 2, which is basically the nested list inside, you actually see that the response is the value is 2, right? Now one of the other things about lists is that lists are heterogeneous as well, which means you could mix up numbers, you could mix up strings, and a bunch of other stuff. So here is an example of a nested list. And you could view this list, and there you go, right? Now, in order to go ahead and play around with lists, there are different methods which you can actually go ahead and use. Let's say if you want to append to a list, you could actually use the append function. And now if you look at your list, you would actually see that the number 4 has been appended to this list. If you want to print the whole list in reverse order, you could use reverse, and this would basically go ahead and reverse the whole list for you. Similarly, if you want to go ahead and pop out the item, you could just use pop, and basically what this does is it pops out the last item in the list. Now, there are a couple of other interesting operations as well, which include extend. You also have insert, which is the exact position where you want to insert the item. So as an example, you could do, let's look at my list and say, hey, my list dot insert to there. Now look at my list, and you basically have there inserted at position 2. This looks interesting. Hello there. Right. Similarly, you can actually delete an item in the list by using del and mentioning the specific item. If you look at your list again, you would notice that there is no longer there. Funny. Okay, so this is what I had in mind for this video. In the next video, we will look at dictionaries and a couple of other interesting things. My recommendation is to please go ahead, try out the various examples if you're unfamiliar with Python or programming in general. There are no specific exercises with respect to this video because this is just an introduction to data types. That's all. Thank you. Please do write in the student forums if you have any questions, and me and my team will get back to you as soon as possible.